In the previous class, we have studied about the nature of the charge that or the property of the charge. During that, we come to know that the like charge repel each other and unlike charge attract each other. That means there is a force between the charges. Now that force is calculated by the Coulomb, and it is the statement given by the Coulomb that is known as Coulomb's law. And whatever the magnitude and the direction of the force is given, that become the Coulomb's force or electrostatic force. Now the statement of the Coulomb force, that is it states that the two stationary point charge attract or repel each other with a force which is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. It is very much similar to that of the Newton's law of gravitation, where we studied about the two masses always attract each other with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. That means Coulomb's law is an analog, or we can say that electrical analog of the Newton's law of gravitation. Earlier, in case of the Newton's law of gravitation, two masses, that is the m1 and another mass, that is the m2, which are placed at a certain distance of r. On that case, that is the Newton's law of gravitation. And due to this, we come to the conclusion that the force is directly proportional to the product of their masses m1 into m2, and the force is inversely proportional to that of the distance, square of the distance between them. And here the force proportionality constant is used, that is the G, the universal constant, gravitational constant, universal gravitational constant, and it is the m1 m2 by the square of the distance between them. So it is the Newton's law of gravitation, where the two masses always attractive in nature, but in case of the charge, we know that the like charge repel each other or unlike charge attract each other. The repulsion and the attraction, that means there is a force. So Coulomb has given, that is the electrical analog of this Newton's law of gravitation, the two charges, let it is the positive charge 1 and another positive charge, that is of the Q1 and it is the Q2. So in these two charges, and these two charges are separated by a certain distance, and that distance is the r. Distance is the r. So it is as similar to that of this one, Newton's law of gravitation, and due to this we have the statement for this Coulomb's law. That is statement we will write later on, but here the force between the two charges Q1 and Q2, that is the charge 1 and charge 2, is directly proportional to the product of the magnitude. Again I am saying product of the magnitude of the charge Q1 and Q2. That is the relation number 1. And another is that F is inversely proportional to the square of the distance between them. The distance between the two charges, that is the r square. Now these two relations, that is very much similar to that of the Newton's law of gravitation. So that is the second relation. Combining these two, we get that the directly proportional to that F is proportional to the product of their charges, that is the Q1 into Q2 by the distance r square. And this relation equation T3 that represents the statement, and that statement is the statement, that is the Coulomb's statement, that two stationary point charge statement I am writing according to this relation statement, or we can say that is state that two stationary point charges with a force which is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So that is the statement, and that statement comes from these two relations. Statement 2 is stationary point charge, which we have considered the 2-point charge Q1 and Q2 is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So that is the statement for the Coulomb's law. That is Coulomb's law. Now, according to this statement, we come to the what the repulsion or the attraction, that means what is the force between the two charges. So on that case, here we will consider the constant of proportionality, that is equal to K Q1 Q2 by R square, where K is the constant of proportionality and its value is the K is written as here K here, that is constant of proportionality. Here K, the value of K is equal to 1 by 4 pi epsilon naught. Where epsilon naught, like this you may write, or this way you may write, that is called absolute permittivity. And the value of absolute permittivity epsilon naught is equal to 8.854 into 10 to the power minus 12, and here we will write the relation, that unit Coulomb square per Newton per meter square. So whenever you put the value here in the K, value of the constant, that is the constant value K is equal to, it become 1 by 4 into pi 3.14 into the value this one 8.854 into 10 to the power minus 12. So that K, the value of the K becomes the 9 into 10 to the power 9, and that is Newton meter square per Coulomb square. So that we come to the value due to the absolute permittivity. And this relation represent that there is the medium which affect the force between the two charges, where in case of the gravitational force, the value of the G is always constant, that is universal gravitational constant. But here whatever the constant we have taken, that value will depends upon the medium, or we can say that at what medium the charge is placed. Where it is in vacuum or air, that means it has the value that is 9 into 10 to the power 9 Newton meter square per K Coulomb square. But if it is placed in any medium, on that case its value will change. So it is not a universal constant, it changes according to the medium. So that becomes the equation number 4. Now in place of this K, we can write F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, and that becomes the equation number 5. Or if we use the numerical problem to solve, on that case the same force value we can write that F is equal to 9 into 10 to the power 9, and in this particular Q1 into Q2 by R square. So that all these are the formulas to find the force among the two charges. Among the two charges, and that is the Coulomb force, that is the electrostatic force. Now, what points we must know that about the constant we have already told, constant that will change according to the medium. If it is changed, that means the force among the charge will change when it is placed in one medium to the another medium. And the maximum value of the force between the two charges, the maximum value of the force between the two charges when it is placed in vacuum or air medium. But when we consider another medium, on that case its value decreases. Coulomb force or the force of among the two charge will decrease. Now we come to the some points, some note point regarding this Coulomb force, that points on note point. Note number 1, that force of repulsion between the force of repulsion, it is when the two charges are like charge, when two like charge are present. When two like charge is given, charge is present, or attraction when there are unlike charge. That is the first point. Now one more point, that is it is the force acting on a line between the two charges, and that is called, it is known as central force. That second, the force between the two charges are along the line, the force between the two charges are from its center, thus it is known as central force. So these two force, whatever may be, if it is attractive or repulsive, this is the central force. That means it acts from center of one charge to the another charge, or from the second charge to the first charge. That is the second, known as the central force. So Coulomb force or electrostatic force is a central force. Now third point to remember, that it is basically hold good for, third point, it is basically holds good for point charge, at rest. 2 point charge are at rest. They are not in a relative motion. They are at the rest position. On that case, this hold good. This means it is only for the point charge at rest. Now fourth point is it is basically an experimental law. It is basically an experimental law. Means it is experimentally proved. The value we can calculate. So these two are the another point to remember. Now fifth point is that two forces are independent of the presence of other two forces. That force, Coulomb force, are independent to the presence of other charges. Fifth point, Coulomb force. Coulomb's is independent of the presence of other charges. Independent of presence of other charges, that means it only acts between the two charges. That is, it only acts between two charges. That means the presence of other charges of no meaning, though they have the another relation with their different charges, but the relation is always between the two. Number of charges will be there, but the force between the two will not get affected due to the presence of other charges. That is the important thing. The Coulomb force is independent of the presence of other charges. It only acts between the two charges. And that is all about this Coulomb force. And one more important thing which to remember, that in case of the gravitational, Newton's law of gravitation, the gravitational constant is universal. But here we use the constant, that constant is the K, which may change according to the medium, or the Coulomb force will change medium to medium. The electrostatic force will change medium to medium. But gravitational force, the mass, the force between the two masses. One more thing, the force between the two masses is always attractive. But here, the nature of the charge affects the nature of the force also. So all about this. Next day we will see the vector form of the Coulomb's law.